Industrial automation is entering a transformative era. Gone are the days when automation was confined to rigid assembly lines, conveyor belts, and fixed robot arms performing the same task in perpetuity. A new generation of technologies is rewriting the rules, driven by artificial intelligence, autonomous mobile robots, humanoids, the industrial Internet of Things, and advanced software platforms. This isn't just an upgrade. It's a full-scale reinvention of how we manufacture, move, and manage goods. In this video, we'll explore how industrial automation is evolving from fixed systems to mobile intelligence. We'll look at the rise of AMRs, collaborative robotics, and groundbreaking platforms like Boston Dynamics Stretch. We'll also dive into the core technologies behind the shift: AI, IIoT, robotics, and cyber-physical systems, and what all of this means for the factories and supply chains of the future. The evolution of industrial automation. For most of the 20th century, industrial automation was synonymous with fixed systems, machines that did one job over and over in tightly controlled environments. These setups were powerful for mass production but inflexible. Any change in product design or volume required expensive reconfiguration. Now, a new wave is challenging that model. Autonomous mobile robots can move freely through facilities, adapting to layout changes and new workflows. Collaborative robots, or Cobots, are designed to work safely alongside people, making automation accessible to even small manufacturers. Humanoid robots are emerging as adaptable, dexterous platforms that can perform tasks in environments built for humans. Add AI and machine learning into the mix, and the result is a more flexible, intelligent, and responsive form of automation. Industrial Internet of Things. The Internet of Things connects every sensor, machine, and process across a factory floor. This connectivity allows operators to monitor conditions in real time, track performance metrics, and remotely control devices. The data collected feeds back into AI models, enhancing prediction accuracy and improving operations over time. Imagine a factory where a robot arm knows when it's about to fail, alerts maintenance, and automatically reroutes production to prevent downtime. That's the power of IIoT. It turns facilities into data-driven ecosystems where everything is visible, measurable, and actionable. Robotics, from fixed arms to mobile intelligence. Traditional industrial robots are still widely used, but they are no longer the only game in town. AMRs are replacing conveyor belts in many settings, capable of navigating dynamic environments without needing magnetic strips or rails. They use LiDAR, cameras, and onboard AI to understand their surroundings in real time. Cobots, on the other hand, are lightweight and easily programmable. They are often mounted on workbenches or mobile carts and can be moved around as needed. Unlike traditional robots that require cages or safety barriers, Cobots work hand-in-hand with human operators. Boston Dynamics Stretch takes mobility to the next level. It's designed to move packages in warehouses, using a smart arm, vision system, and AI to adapt to different shapes and layouts. Robots like this show us what happens when mobility meets intelligence. Additive manufacturing, 3D printing. 3D printing is reshaping the economics of production. With additive manufacturing, companies can make complex parts on demand, without the need for molds or mass production lines. It's a game changer for prototyping, small batch production, and design flexibility. Beyond reducing waste and speeding up development, 3D printing allows for rapid iteration and mass customization. As materials improve and costs fall, additive manufacturing will play a bigger role in both production and maintenance workflows. Augmented and virtual reality are not just for gaming, they are tools for transforming industrial work. Technicians can use AR glasses to see step-by-step repair instructions overlaid on physical equipment. Engineers can design and simulate processes in virtual environments before implementing them in the real world. These technologies improve training, reduce human error, and shorten downtime. They also help bridge the skills gap by guiding workers through unfamiliar tasks with immersive visual aids. Autonomous mobile robots, AMRs. AMRs are fast becoming the backbone of internal logistics. Unlike older AGVs that follow preset paths, AMRs use sensors, cameras, and AI to map their surroundings and make decisions on the fly. They can avoid obstacles, reroute when necessary, and collaborate with both humans and other robots. They are ideal for transporting materials, picking inventory, and even delivering goods between workstations. Their scalability and ease of deployment make them attractive for companies of all sizes. AMRs don't just reduce costs, they unlock operational agility. One standout is MIR, or Mobile Industrial Robots. Their platforms are fully autonomous, AI-enabled, and capable of handling payloads from small bins to full pallets. They are being used everywhere from automotive plants to farmer warehouses to automate repetitive and labor-intensive tasks. Humanoid robots and advanced manipulation. Humanoid robots are stepping in where traditional machines fall short. Their human-like form makes them ideal for tasks in environments designed for people, no need to redesign the workspace. They can walk, climb stairs, use tools, and manipulate objects with surprising dexterity. They are not limited to lifting or sorting. These robots can perform quality inspections, work on complex assemblies, and even learn new skills by watching humans. While still early in development, humanoid platforms like Apptronic's Apollo or Sanctuary Eye's Phoenix are closing the gap between robotic potential and human flexibility. In the long run, humanoid robots may help solve labor shortages, especially in physically demanding, repetitive, or dangerous jobs. And because they are software-driven, they can be reprogrammed to handle new tasks overnight. Boston Dynamics Stretch. Stretch represents a new class of robot, intelligent, mobile, and warehouse-ready. It was purpose-built for unloading trucks, moving packages, and navigating tight, high-paced environments like distribution centers. With a custom robotic arm, a vision system that identifies box sizes and positions, and software that dynamically adapts to the environment, Stretch eliminates the need for fixed automation in many logistics workflows. Companies like DHL and Walmart are already testing or deploying fleets of Stretch units to reduce manual labor and improve throughput. This robot isn't just lifting boxes, it's lifting the logistics industry into a smarter future. The Smart Factory. The future of automation is not about standalone robots, it's about orchestration. A smart factory integrates robots, sensors, software, and humans into a unified, intelligent system. In a smart factory, every asset is monitored in real time. AI continuously analyzes data to detect inefficiencies, predict failures, and recommend adjustments. Workflows adapt automatically to meet shifting demand. AR headsets assist human workers with tasks, while AMRs and Cobots coordinate seamlessly to keep things moving. This level of integration creates a production environment that is not only efficient but also resilient, able to adapt to disruptions, whether they come from supply chain shocks or sudden shifts in consumer behavior. Benefits of next-generation automation. The benefits of intelligent automation are substantial. Productivity increases as machines operate around the clock. Flexibility improves as robots adapt to new products and processes. Quality control becomes more precise with AI-powered vision systems. Safety is enhanced as robots take on dangerous tasks. Operational costs drop thanks to reduced labor needs, energy savings, and fewer errors. And perhaps most importantly, these systems scale. Companies can start small and expand as needed without huge capital investments. For organizations willing to embrace the change, automation is no longer just a cost-saving measure, it's a strategic advantage. Of course, this transformation doesn't come without challenges. Integrating diverse hardware and software systems takes time and expertise. Cybersecurity is an ongoing battle. Automation changes job roles, which means workers need retraining and support. There are also ethical concerns around workforce displacement, AI transparency, and data use. And while automation brings long-term savings, the upfront investment can be significant, especially for small to mid-sized firms. The transition must be handled thoughtfully, with a focus on inclusive growth and human-centered design. By 2025, intelligent automation will be the new normal. AI will be embedded across operations. AMRs and Cobots will be ubiquitous in factories and warehouses. Data will flow in real time through IIoT networks, enabling dynamic decision-making. And humanoid robots will begin entering the mainstream for complex or dangerous tasks. The companies that lead in this space won't be the ones with the most robots, they'll be the ones that build the smartest, most adaptive systems, combining human creativity with machine efficiency. The future of industrial automation is not just a step forward, it's a leap. With intelligent, mobile, and collaborative machines at the helm, the way we manufacture, distribute, and work is being fundamentally redefined. From AMRs navigating factory floors to humanoids handling complex tasks, we're seeing a shift toward systems that are as adaptable as they are efficient. This isn't the factory of tomorrow. It's being built today. The question is, will your organization lead this transformation or struggle to catch up? Thanks for watching.